Don't mark the screen. Okay. So first open the data set. So if you go to the menu option, just open, then production data underscore 12. Okay. Now the data is open. So first thing, in the last class also I have stressed this point. Always start your session with a log file. So the command for using a log file is log using followed by a file name of your choice. I am using, let us say, production underscore 12 data analysis. Okay. So if you want to save the file as a text file instead of SMCL, you can also write text. Okay. So now I have opened a text file. If you want to see the command again, so it is log using the name of the file. This is I have specified. After the comma, I have written text. I want my log file as a text file. If you don't specify, the default is SMCL, that is a stata file format. If you are using click and play type of stata, then it will open as a HTML also. Okay. So, but now for demonstration, I'll be using a text file. So first step, once you import the data, is about have a look at the type of variables which are there. Okay. So just scroll down and see what are the variables that you have. So you have a farmer ID, you have which season, which district, which village. Then we have the variables like age, sex, education in terms of years of education, what is the primary occupation, what is the land type, what is the area, and all other things are there. Okay. With respect to production also, you have yield, you have area, you have average price. All these details are there. Okay. So just scroll down and see what variables are there in the data set. Then in the properties window, just scroll down and see how many observations are there. So you can see here in this data set, we have 219 observations. Okay. Now, once you done this, simply type describe. Okay. Simply type describe. If you don't type anything, if you don't give any variable name after the command describe, it means that you're asking Stata to describe the entire data set. If you specify only one variable, for example, if I say describe and I give age, so it will give the description of the only variable age. So what is the variable name? It is a numeric variable. That's it. But if I simply type describe and don't give any variable name, it will describe all the variables which are there. So in the last data set that we have used, which means yesterday what we have done, in that labeling part was not done correctly. But here you can see all the variables are properly labeled. Okay, all the variables are properly labeled. The description is clearly given. But you can see that some of the variables are in string. For example, season is given in string. District name and village name, obviously it has to be string, but primary occupation is also a string variable. Sex is also a string variable. Land type is also a string variable. So there are many string variables. Remember what I told you? Whenever you have a string variable, you cannot directly use it for analysis. In most of the cases, you need to convert it into a numeric variable. You can convert it into a dummy variable or categorical variable in any way. The purpose of choosing this specific file or this specific data set is also that if you get such a data set where many variables are string variables, how to clean that data set and how to convert those variables into numeric variables so that it will become easy for you to analyze later. Okay, now you know that there are these many variables are there. Just visualize the data once. Simply type browse. Okay, this is the data of Philippines. Okay, and this is the data of rice. So you can see that one variable sex, which is string, primary occupation of the farmer. Some are farming, some are employees. Again, it is a string variable. Secondary occupation is a string variable. But I don't recommend you to enter the data in this format. Always use quotes. If you are entering data in this format, it is very difficult to clean the data. You will have extra work to do, which I will show you now. Okay. So other variables are numeric. So just scroll down and see what are the variables that you have. Okay. There is no issues as such, except that few variables are string. Now go to the Word file and see what is the question. Okay. So it asks you to summarize the data so that you see the mean, standard deviation, min, max, all those things. Okay. So which variable you want to summarize? Let us use summarize option. The shorthand for summarize is sum. I will take only the continuous variables because mean is not really meaningful if it is a categorical variable. So I will take age is a continuous variable. Years of education is again another continuous variable. Then plot size is a continuous variable. Okay. Then yield per acre in kg, that is also a continuous variable. Price is a continuous variable. Let us assume that this many continuous variables that I want to examine the summary statistics. So the command is very simple, sum followed by all the variable names. And remember, you need not to type any of the variable names. You just move the cursor over the variables, and if you click on the arrow, the variables will come. Okay. So now you can see that all these means, standard deviation, minimum value, maximum value, everything is given. So for example, if you take the years of education, on an average in this data set, 8.5 years is the average education, minimum being 1, maximum being 14. Uh, Kindly mute yourself if someone is not muted. Next, we have area as a variable. On an average, 1.17 hectares is the land size. Minimum is zero point 0.1, maximum is 0.3, 5.3. So this way you can summarize the data set. Okay. So alternate option is we can always use tab stat. Okay. See, so what command I have used? I have, instead of using summary, I have used tabstat. Tabstat gives you additional options to specify what statistics that you want. For example, you want mean, minimum, maximum, skewness, kurtosis, standard deviation. So whatever things you want, you can specify. There is probably around 20 to 25 different statistics are available with tabstat. You can use any of those depending on what you want to see in the data. So it all depends upon what research questions you have and what kind of descriptive statistics you wish to take. Okay. Then there are certain qualitative variables. For example, one variable is sex, okay, or gender. So in this, you cannot take summary. And second problem is that this variable is in uh, what you call string variable. So even if you type sum and give, it will say no observations are there to take mean. So any variable which is in textual format, you cannot take mean because there is no numeric value associated with it. So what you can do is you can tabulate it. So tabulation is nothing but getting a frequency table. Okay. So you can see that there are 24 female and 195 male households. Then you tabulate the another variable, that is primary occupation. So you could see that farming 206, but observe here This is why I say that you should not be typing the things, instead of you should use coding. Some have coded as farmer, some have coded as farming. Both essentially mean the same thing. So now you have discovered it after tabulating. Now you have to correct this and bring it into a single category. So majority of the data is from the farming households. Okay. Then you can tabulate the other variable, land type. Okay, so lowland farmers are 191, upland is 12. Now again tabulate soil type. So the most common soil type in the region is clay, followed by loam, sandy, and sandy loam. Okay, so this is how whenever there is a categorical data or qualitative data, you can use tab. You can also use two-way tabulation. Instead of say tab soil type, you can add another variable with it. So soil type with land type. So now you get a two-way tabulation, right? So in this axis you have land type, and in rows you have soil type. Okay, so this way two-way tabulation also you can do. There are many other options that you can use with the tab option. What you need to do is explore the help command h space tab, and whatever your type of table that you want to have, just explore how it can be done. Another important aspect of visualizing the data, particularly when it comes to a quantitative variable, a continuous variable, is its distribution. In yesterday's class also, I have highlighted that if it is normally distributed, then there are many issues in using the variable for hypothesis testing or that kind of thing. So, and also if there are outliers, and if it is not normally distributed, you will have complications. So first we have to examine the distribution also. I will demonstrate using two or three different kind of data visualizations when it comes to distributions. I will take one common variable, that is production or yield per acre. Let me take that variable, and I will start with one of the most common graphs for visual depiction. To be frank with you, this is my favorite graph, that is box plot. So in this, the command is simple: graph, which type of graph you want, box, which variable you want to, production. The name of the variable is this, but this is basically yield per hectare or yield per acre. Just click on it. Okay, so data will take some time. I hope you can see the data now. So in a graph plot, this represents the first quartile, the lower line represents the first quartile, upper line represents the third quartile, this is the median, and these dots which are there, they are the outliers. So obviously, when you look at this, when average productivity is around 900, some farmers have a productivity of 3000 plus, and some even have 5000. Probably there could be a data entry error, or examine each of those data points individually, which is those farmer who has a 5000. Examine who interviewed that particular farmer. Okay, then call that farmer and confirm. And if that has a story to tell, for example, that farmer may be having a brand new variety, or he may be award winning farmer, whatever may be, examine why that point is there. If it is a data entry error, then rectify it. If it is a data collection error, the enumerator did not collect the data itself, he voluntarily filled it on his own, examine that. And this also indicate that the distribution, there could be issues with the distribution. Okay, so now I will show you another way of plotting it, that is k density plot. So k density production. Okay, and I will superimpose a normal curve over it. Okay, I will plot it using k density plot, and I will superimpose a normal curve over it. Okay, so if it were to follow a normal distribution, it should have followed this curvature, but now it is kind of skewed, slightly skewed to the left side. So there might be some issue. Let us examine this for another continuous variable, that is area. And again, the command is very simple: k density followed by the name of the variable. Just add a comma and write normal. If you don't write normal, it will not superimpose a normal distribution curve. See, again, it's not actually normally distributed. There is some deviation from, but it's not a test that whether it is normally distributed or not. If you, it's a graphical way of looking at things. If you want formal test of normality, then you can go for Jarque-Bera test, or there are many normality tests which are available with the Stata. So let me do one thing. I will take logarithm for that same variable. Okay, egen. Simply you can use gen log of prodlog is equals to log of the variable. What I am doing, I am taking logarithm for the same variable. So which command I am using? I am using generate command. Okay. What I want Stata to do is create a new variable. The name of the variable is L underscore prodlog, which equals to log of this particular variable. Why I am using single equivalent sign here? Because I am assigning the value to this variable. This is not already defined. So simply click enter. Two missing values are generated. Okay. Because it could be 0 or missing value or something, some problem with it. Now, if I do k density plot for the new variable which I have created, can you see? So the normal curve and the k density of the actual variable, so both are closely matching with each other. It need not to completely overlap. If it is moving almost parallelly also, it's perfectly fine. So whenever a variable is not normally distributed, it is better you transform it using log transformation or other appropriate transformation. So there are many other transformations like arcsine transformation and other things, which all depends upon which type of variable you have, whether it is a ratio, whether it is a continuous variable, whether it is a proportion, how is the distribution of the proportion. It's a vast literature. But in general, for continuous variables like area or yield, income, so if they are not normally distributed, what we usually do is take the logarithm and then use it for further analysis like regression and other things. So the purpose of showing you to draw these graphs is that, so all the continuous explanatory variables that are there, okay, please make sure that you use a box plot, you draw a k density plot, or even you can use a simple histogram. Okay, let me use a different variable. So expenditure on fertilizer, amount spent on fertilizer in Philippines currency. Okay, okay. Then again here also you can say superimpose a normal curve. See, so this is also kind of not a normal distribution. It's kind of skewed towards the left side. So use any one of the distributions and do the analysis. This has to be the first part of the analysis. Okay, this has to be the first part of the analysis. Next, if you just go and see which questions that we have, I have already done kernel density. I have already done the summarize. So I think correlation between area and yield should not be such difficult task for you. because you have already examined that particular command. So prodlock is one variable and another variable is area. So simply if you type CORR, you will get, right? So correlation is 0.73 and simple plot of this relationship, which I think, let me use my do file so that I can save time on it. I will share the do file at the end of the session, so don't worry about it. So I will show a way of plotting scatter diagram. Okay. Okay. So there is a way to draw a scatter diagram. So the option is two-way scatter. Age is the one variable. Education is the another variable. Okay. Or you can do prod lock and area. So production and area. What I am doing is a scatter diagram. See, you can clearly visualize the trend. As the plot size increases, on an average, yield is also increasing, except some outliers which are there. Okay. So this is how you can use stata graphics. One more thing that I wish to show you. Okay. I hope all of you can see the plot in the share screen. If it is not, just let me know. So what currently you are seeing is a simple screenshot. I mean, simple graph, but you might want to change some of the things. For example, you want to change the font size of this. You want to change the font size of this. You want to change the background color, and you want to do all these changes. So what you need to do is right click, start the graph editor. Okay. Once you click on it, all the options will come. Okay. And here there is an option for start recording. I want to, I want all of you to observe here. There is an option for start recording. If you click on this, whatever changes that you are making in the graph, it will be saved. For example, you are changing the background. Let me start the recording. Now it has started. Now what I will do is I will change the color of the region. It is now light bluish gray. I will make it into a white background. See, I have made it into a white background. Then years of education. So it is in medium small. I will make it into very small. And age, again, I will make it into very small. And even this axis also, I want to make it small. Is it option there? Yeah. Here also I can make it small. Okay. So now I have done all the changes. Now I will say what I need to do is again click on the same option. Initially I started the recording. Now I want to end the recording. So I will ask it to end recording. I will save it as scatter plot. Okay, I will save it as scatter plot and I will stop the graph editor. Now I will save the graph also as some graph. Okay. Why I asked you to record changes that I have done is I will show you one more. So initially I plotted age and education. Now I want to plot the production and area. Okay, production and area. And this plot also, I want to apply the same changes as that of my earlier plot. Again, I have to start graph editor. Then again, I have to click here. I have to change it. I have to change another thing. Instead of that, if you go here, Okay, if you go here and in this drop down window, you can see that last recording scatter plot. So in the last graph, whatever formatting changes that I have done, that can be readily applied to this slide without me doing anything. See, all the things have changed. The font size has changed, the background has changed, it has come to small, it has come to very small. So all the changes are automatically applied. So when you are making say 4 or 5 different graphs and all the graphs you want to have a same formatting, because in if you want to submit it into journals, you cannot have 4 graphs with 4 different styles in formatting. Though you are using different graphs, formatting should be the same. So saving the formatting style using graph recorder is a very handy tool and it can save lot of time. Okay, I don't want to save this. Okay, now the next question that I have is the question number 5. Generate a new variable that indicates yield is above 3000 kg per acre. Okay, yield is above 3000 kg per acre. So what I'm asking is create a dummy variable. The variable will take the value 1 if the yield of that particular farmer is greater than 3000 kg per acre. So how you do? You can use generate command, okay, and name it as higher yield is equal to 1 if if prodlock is greater than or equal to, I hope you are clear with this command till now. So what I'm doing, I'm using generate command and I'm specifying a new variable name for it and I'm assigning it a value of 1 if the production is greater than or equal to 3000 units. Okay, here I'm using greater than sign. That is why I'm not using double equals. If I want to assign the value 1, if the production is exactly equal to 3000, I should have used two equivalent signs. What I'm doing, it is greater than or equal to 3000. Okay. Only 6 units have a yield of greater than 3000. Why is it giving 213 missing values generated? It is generating missing values because I have assigned a value of 1 only if the data has a production of greater than 3000. If it is less than 3000, I have not assigned any value to it. So in the next step, I have to assign it a value and I have to use the command replace. Why I'm using replace command? Because in the previous command itself, I have generated the variable. When the variable is already there, you cannot generate it again. So I'm asking replace higher yield is equal to 0 if it is less than 3000, I want the value to be assigned as 0 when the production is less than 3000. Okay, so I'm using the command replace because in the previous step itself the new variable generate has been used. When generate has been used, this new variable is already created and already in the data file. When it is already in the data file, you cannot create that variable one more time. Okay, now you tabulate the new variable that you have created. You could see that only 6 farmers have a yield of greater than 3000 and other 213 have yield of less than 3000. Okay, so this is how you create new variable from the existing set of variables. Create a simple histogram of fertilizer expenditure that I have already done. Seventh is I will share you the command for this. This is a slightly more nuanced and more complicated thing. Okay, but the purpose of showing this graph is there are different ways to visualize the same thing. Suppose I want a histogram of fertilizer use, okay, histogram of fertilizer use, and I want to see if the fertilizer use differs across the gender. So I can always use the command by. Okay, I can plot the histogram of fertilizer by sex. So it will give a kind of this kind of graph. Okay, so you can interpret that majority of the females use lesser fertilizer compared to males, where it is uh, distribution is slightly different. Okay, higher number of farmers, you can see more proportion of farmers using higher level of fertilizer, but most of the women use less fertilizer. So that is what you can say. But this graph doesn't look good for the eye. So what you can do is you can use superimpose the two different graphs. Don't worry about the command. I will share with you all. Uh, I have not created the dummy variable for sex. Uh, Let me create generate male equals to 1 if sex. Why this command is looking different to you? I have used the generate command earlier also, but why am I using a two quotation mark in creating this new variable? Because if you remember tabulation that we have done, so this variable is a string variable and it is given in text as male. So whenever you are referring to a string variable and value of that string variable, which is in text, you have to use double quotation mark in case it within the quotation mark. So how I create a new variable from this? Generate male is equals to 1 if sex double equals. So did this command run or is there any error? Can somebody unmute and respond? Am I able to successfully run this command or is there any error?
It successfully ran.
Values for the female also.
Okay. Sorry, Jagdish.
We have not yet assigned the values for female, sir.
Okay, that is one thing. Tiwari?
Sir, it successfully generated, and then again we have to replace female by giving some value like 0.
Okay, so let me do that. Replace male is equals to 0 if sex double equals female. Right? Now,
Sir,
let me
you should have.
tabulate. Let me tabulate the variable. No observation.
It's case sensitive, so I think mail has to be written. Correct,
Exactly.
sir.
So the problem here is in the first command, I have not used M capital and here also F capital. So when you don't use M capital, the command will run, but just see the result here. 219 missing values generated. The missing value should have been only 24 because female I have not assigned, but 195 male it should have had some value. So only 24 missing value should have been created, but all the data set it has created a missing value because it is case sensitive. So what I need to do, first drop that new variable. So dropping the variable is by drop male. Again create that variable, but this time make sure that you enter it as caps. See here, only 24 missing values are created now. 24 missing value corresponds to female. Again replace, use F capital. Okay. Now tabulate the variable male. Now you can see that the new variable has been generated successfully. Okay. Now I will run the graph option. Ah, there are some issues. Give me a second. Okay, I will share this at the end. Okay, don't worry about it right now. Uh, I will explain the same graph. So here what I have done is I have superimposed male and female amount spent on fertilizer in a same graph. So female headed households, they are only till this. And I mean at the lower end of fertilizer distribution, majority of the female households are there. But male headed households are there across all the region. This needs lot of refinement. You need to change the bin size and all other things that you can do later. Let me tell you another shortcut for creating a dummy variable. So let us go back to our variable sex. Okay. Another way of creating a dummy variable without typing anything is xi dot variable name. I hope you are clear with the command. It's a simplest command. First, use the prefix xi, then I dot followed by the name of the variable for which you want to create the dummy variable. Run it. So what is the result that you got? So I6 underscore 1 for sex is equals to female is omitted. So whenever you have a dummy variable, I mean categorical variable, you should always you cannot create two dummy variables for this. You need only one dummy variable. That is what it has done, and it has created a new variable underscore I sex underscore 2 when sex is equal to male. Okay, so let us tabulate that variable and see how it has created. So it has created a dummy variable where 1 is male and 0 is female. Okay, you just need to rename this variable as rename the new variable that you have created as something. Okay, so now you have created a new variable with just one command, that is xi I dot sex. Okay, so this is easy way of doing it. But the disadvantage is that this can be done only for one variable. For example, let me tabulate another variable which is of categorical in nature. Let me take land type. There are three categories in land type: lowland, medium, and upland. So how many dummy variables you can create from this? Should we create 3 or should we create 2?
Two, sir.
Two.
So whenever there are 3 categories, we need to create only 2 dummy variables. Okay. So let us do that. Xi I dot land type. Okay. Then just scroll down. See, you have 2 dummy variables. One is for medium and another one is for upland. So lowland has been taken as base category. That is what we do. We have to create only 2 dummy variables. Okay. Now I will create dummy variable for another variable, that is soil type. So how many soil types are there? 4. From this you need to create only 3 dummies. I will do that. Xi I dot soil type. You can see 3 dummy variables. But the unfortunate thing is, earlier we have created 3 dummy variables I dot land type 1 to 3. They have been automatically deleted. So as soon as you use xi for some other variable, the previously created dummy variables will be deleted. So this is the disadvantage. How to overcome it? You just need to rename these variables as, for example, this is nothing but loam. Okay. Rename the second variable. What is this variable? You can see here it is sandy. So rename that variable as sandy. Then rename the another variable as sandy loam. Okay. Now you can again type xi I dot, which is the earlier variable that we tabulated, land type, right? Land type. Now we will get two land types. So just rename them as, rename the variable is this, and how, what you need to rename it as, medium. Rename land type 3 as upland. So now you have all the dummy variables you have created. Loam, sandy, sandy loam for the soil type, upland and medium for land type. So this is an easy way of generating the dummy variables. Okay. Question number 7 we have done. Question number 6 we have done. Okay. So let us move on to question number 8. So calculate the net returns from the data and summarize the net profit. So just see what are all the elements that are required to calculate the net returns. Can anybody respond? How do we calculate net returns? What do we need for calculating net returns? What is the formula for net returns? Net returns is equals to net returns or profit or income.
It is gross returns minus total cost.
Yeah, thank you, sir. Gross returns minus total cost. Is it clear? Net returns is equal to gross returns minus total cost. How do you get gross return? So that is nothing but price multiplied by quantity, okay, minus total cost, minus total cost. So that you need to do. So here from this data, what data do we have? So we have yield per acre, right? We have yield per acre. So let us generate a new variable, generate total production is equal to, total production is equal to production multiplied by area. Production multiplied by area. So is this command clear? I am creating a new variable, total production, which is production multiplied by area. Why I am multiplying by area? Because this is production is in per unit area. So I have to multiply with area. Okay. Next, I need to generate, okay, I need to generate gross returns. Gross returns is nothing but price. See, price is here multiplied by total production. So again, I'm using the command generate. Gross returns is equal to price. Star is a symbol for multiplication, which is common in across the platforms, multiplied by total production. Now, what are the elements of cost we have here? Okay, cost, you can see the data set. So you have the details of amount spent on seed, amount spent on fertilizer, amount spent on pesticide, amount spent on hired labor, amount spent on other expenditures. Okay, so these are all the cost elements. you need to create another variable which is a sum of all those. Okay, here I'm using a different command. So give a little bit attention here. First, I will write the command and then I will explain why I'm using this. Seed, fertilizer, pesticide, hired labor, others. So in the earlier cases, I have used generate command, right? But here I'm using eGenerate command. eGenerate is a close cousin of generate. Why we use eGenerate command is whenever we generate a new variable, which is a slightly complicated function of other variables which are already there. Here it was simply multiplication, but here I'm doing row total. I can also simply type seed plant plus fertilizer plus pesticide, it will work. But the problem is, suppose some farmer is not using any pesticide. So there the data will be a missing value. He is not using any pesticide, we won't write it as 0, but it will be a missing value. If there are any missing value amongst any of the data points, entire observation will be considered as missing. You cannot add missing to some existing data if you use plus symbol. So instead of using plus symbol, we use row total. Whenever you use row total, missing value will be considered as 0. So whenever your data has missing values, always use row total when adding. Okay. Now you have got the total cost, you have got the gross return. Simply what you need to do is generate net profit is equals to gross return minus cost total. Okay, now sum. Okay, so there are some farmers who are getting negative returns, that is fine. So on an average, I don't know which is the currency of Philippines, but 21,390 Philippines currency is the average net returns that farmers are getting. So you can also use a K density plot for the same. So you can see that it is skewed. The distribution is highly skewed. So when you, if you want to examine what are the factors which determine the net returns of the farmer, or you want to use a production function using net returns or gross returns as a dependent variable, it is better to take log and then use. Let me take a log to this. Log of net return is equal to log of the variable net profit. So generate, the new variable name is L underscore net return, which is equal to log of the variable which I have created in the previous step. I'm just taking the logarithm of that. Okay. So now let me graph it. See how closely it matches to a normal distribution. So this variable you can use in regression or any kind of analysis that you want to do. Okay, so we are done with question 8. I think question 9, most of the part we have already answered. Total expenditure on fertilizer and pesticide you can always do. Log of yield we have already examined. Numeric variable called male for sex we have already done. Variable called farmer which indicates respondent's primary occupation is farming. Okay, let us do one thing now. Tabulate what is the variable? Primary occupation. So I'm tabulating the variable primary occupation. From this, I want a variable which is the name of the variable is farming. It should take the value of 1 if farming is the main occupation, or else it has to take the value of 0. Can you try this on your own? I will give, say, 5 minutes time for you. It's 4:57 now. I will also take a quick break till 5:02. And can you try this command? What I want is a new variable called farming. It should have a value of 1 if he is a farmer. Remember, farmer here it is 4, farming here is 206. Both of them should get a value of 1, which means there should be 210 observations with value of 1 and 9 observations with value of 0. Just try to uh, do that. I will take a quick break and I will come and explain easy way of doing that.
Sir,
Is it okay?
1 minute, sir.
Yeah.
Sir, actually, the file which you have sent, no, that's not getting opened, sir, in Stata. It is
Which
showing
one?
not in Stata format.
Are you using Stata 12?
Sir.
Then the data, it's already in Stata 12 format only. Let me save it again as Stata 12. Okay. Let me share it again with you.
Okay, sir. Thank you.
Save as. Okay, I am saving it as Stata 11 format itself. Hope it won't have that issue with. Can I share it in the Zoom chat itself? Can you download and use it?
It's better to mail, sir. I could not access that, even the text file.
Okay. Okay, I will do that.
Thank you, sir.
Okay, so all of you try that command and we will meet in another 2-3 minutes. Okay, just try and we will see how it goes. Okay, how many of you could do it? Any success?
No, sir.
You could do it? Okay. No?
No, sir.
Okay. Okay. So one way of doing it is generate new variable called former is equals to 1 if primary occupation is double equals quotation mark farmer, right? 215 missing values generated because all others it is given something else. Now again you have to do replace farmer is equal to 1 again if primary occupation is another is there which is farming. Farming and farmer all mean the same. So again you give double quote farming. Now 206 changes have been made. Now replace farmer is equals to 0 if primary occupation is employee. So if he is not a farmer, you want it to be assigned a value of 0, right? If he is a farmer, we have assigned the value of 1. If he is not a farmer, we are assigning a value of 0. Replace farmer is equals to 0 if primary occupation is, what is that another one, laborer, or I can write it in a same command using or primary occupation is piggery or the primary occupation is teacher. Oh, sorry. Farmer is equals to, I will write separately itself, if so similarly you have to write, sorry, similarly for all the occupations you have to write and then you have to create a dummy variable. But the simplest way of creating a dummy variable is, so here I have written, please mute. Okay, so let me drop that variable. So I will generate the variable farmer again is equals to 1 if primary occupation is, farming. I have to use 2 equals. I have to use quotation marks because it is string variable. I have to use quotation marks. Okay. Now, instead of typing replace farmer is equals to 0 if he is a labor, if he is a employee, if he is a piggery, if he is teacher, instead of writing all those things, I can use another command, replace farmer is equal to 0 if missing farmer. So I'm tweaking the command what I'm asking Stata is, in the first step, I have replaced the value as 1 if he is a farming and if he is a farmer. All others will be generated as missing value. In this step, what I'm asking Stata is, if it is a missing value, replace that missing value with 0. I hope I'm making sense. In the first step, I have created the variable farmer and given it a value of 1 if he is farming or farmer. Then 9 missing values were created. In this step, I'm replacing all those 9 missing values with value of 0. So this is easy way of doing it. Now, if you tab farmer, you could see that 210 farmers who have farming as a major occupation, all other 9s who are not having major occupation as farming. So using missing as a kind of command makes your job lot easier. Okay, so creating dummy variable, question number 10 for soil type and land type, we have done it. Average fertilizer expenditure in each village, you can use egen function for it. Okay, you can use egen function for generating fertilizer cost and all other things, by village, by state, by district. So all those things you can do. If I have the command, I will show you. I will show this command. Don't worry too much about the anatomy of command and how to remember these commands. Nobody remembers these commands. So if you know that if you want to create fertilizer expenditure by district, if you know that you have to use egen command, then you can go to help egen and get the command. Or if you are having the do file that we are doing right now, then you can change the variables and get what you want. So here is the command. So what I am doing here is I am generating fertilizer average by village. For each village, how much is the average fertilizer expenditure? That we can easily create using this command. But I have to use egen whenever we have a complicated creation of variables, which a variable is a function of some existing variable with some statistics involved, then we have to use egen, not simply gen. Okay, so now you can tabulate fertilizer average with village. Okay, so each village fertilizer expenditure, how much it is there, that will be given. Okay, instead of tabulating, you can summarize fertilizer average by, I don't know if it runs. Okay, sorry, it's not taking. Mean village is a string variable, so you cannot summarize over it. Village needs to be converted into numeric variable, then you can do this kind of analysis. You can tabulate or you can summarize by converting it into numeric variable. So question number 11 is also done. Question number 12. Generate a dummy variable indicating if the farmer received more than the average price received by the sample farmers. Can anybody tell me how to go ahead and do this analysis? Generate a dummy variable indicating if the farmer received more than the average price. So I need to create a dummy variable. Let us call it as higher price, and it should take the value 1 if the farmer got more than the average price. How we need to go ahead in this case? So I want to create a new variable, higher price, and it should take the value 1 if the price that farmer got is greater than the average price. How we can do this?
Sir,
Hmm?
first we have to take the average price what all the farmers are receiving. Then based on this, what the actual price, average price come, that let's suppose 2000 rupees, then more than 2000 we can create a dummy variable taking this 2000, this more than or equal to option.
Yeah, very good. So first we need to get the mean value of the price that farmers are getting or average price farmers are getting. Let us calculate mean price. So the mean is 13.27. So now you can create a new dummy variable, generate higher price is equivalent to 1 if price received is greater than or equal to 13.27. Okay, generate higher price is equals to 1 if price that farmer is getting is greater than 13.27. Where did the 13.27 came from? It is the average price farmers are getting. So this dummy variable will create this dummy variable will indicate if the farmer is getting higher price than the average price in the sample. Now you need to replace the variable higher price by 0 if he is getting less price. So instead of writing if price is less than 13.27, I'll use the earlier trick if missing. Okay, I'll use the earlier trick, that is using missing as a uh, what you can command to create the or replace the missing values. So now tabulate. So now you see that 91 farmers got a higher price than the average price, whereas 128 got less price. Now the next question is, what are all the correlates of farmer receiving a higher price? Or the question is, can you characterize the farmers who got the higher price than the average price? Or who are the farmers, which type of farmers got a higher price than the others? So what kind of model you can use? Can you think of a model? The correlates of getting higher price, determinants of getting a higher price. So using this dummy variable we have created, can we run a Probit or logic model? So if you want to run Probit or logic model, so the dependent variable will be the dummy which we have created, higher price, as a function of so different attributes of farmer, whether the male farmer are more likely to get a higher price, whether older farmers are more likely to get a higher price, or is it education? Yeah, is it education, or is it a particular area, whether the small farmer are more likely to get higher price, or is it the large farmer, whether tenure has anything to do with it? So all these things you can take and run a Probit or logic model. Okay, so just before that, let me check how the variable tenure is defined. Okay, so I need to convert it into dummy variable. Presently it is in string format, right? So let me do a quick Probit regression. Probit dependent variable is whether the farmer got higher price or not. So that is my dependent variable. In regression, in Probit, in logic, all types of regression, the first variable has to be your dependent variable, followed by different independent variables. Okay, so let me take, just for the example, I will take age. Okay, then I will take sex, I will take education, I will take land type. Okay, no land type. Land type has nothing to do with it. Okay, education. Then I will take tenure. Just for the example, I will take tenure. Okay, I will try to run. Why is it saying no observation? If you browse, there are observations, but why is it saying no observations? Any guesses? What might be the error?
Tenure, sir.
Why?
Dummy is not created because that is in a string variable. So
Okay. So let me remove tenure. Because the variable sex is also a string variable. So even if you have one string variable, the regression will not run. Okay. So you have to convert all those variables into string variable, numeric variables. But there is an easy way around it that is called as xi prefix. So if you just type xi and use a colon before typing the probit, and wherever categorical variables are there, string variables are there, just type I dot. Okay. So is this command clear to you? First, you have to use a prefix that is xi and then use a colon, then use this whatever command that you want to do, probate, regression, logit, whatever you want to do, use that. But whenever there is a string variable which is qualitative in nature, which is categorical in nature, just type I dot tenure, I dot 6. Then run a regression. Okay. So first in the result, let us examine. So from the variable sex, it has omitted female and it has created a dummy variable for male. The name of the variable is this. Okay. Leasehold is omitted and another two dummy variables are created. 2 and 3 are created. So the results of those dummy variables are given. So I6 underscore 2 stands for male. This is tenure 2 and tenure 3. So the results have come. So if you don't want to create the dummy variables, then the easy way out is using xi prefix. But in this, I'm not going into too much details about the statistics. So, but if the p-value is less than 0.05, only that variable is significant. Unfortunately, none of the variables are significant here. But if it is significant, assume that the p-value for age is say 0.01 instead of 0.1. Then you could say that if the farmer has higher age because it has a positive coefficient, if farmer has a higher age, he is more likely that he will get a higher price. But you cannot explain or interpret the coefficient directly. Those who have studied econometrics, they know that in case of index-based models like logit and probit, we should always take marginal effects. So the code for getting a marginal effects is MFX. Simply MFX. So you run a probit or logit model followed by MFX. You should get the marginal effects. So what does marginal effects tell you? For 1 unit increase in age, by how much the probability of getting a higher price increases. So you can interpret the coefficient as like in terms of probability. Okay. You can interpret the coefficient in terms of probability if you want to, if we get a marginal effect. So also you can plot the results of regression. I don't know if this command works. Okay. This will run only with margins. I don't know if it runs. Okay, it's giving overall only. So you have to use margins with all the explanatory variables. Then you can use margins plot. So you will get a plot of marginal effects of different variables as well. So this is how you do a Probit regression. Similarly, you can do normal regression also. Let me show you. Instead of taking higher price, let me take price itself and do a normal regression, right? Okay. So I will again use xi prefix and I will use I dot sex and I will also use I dot district. So whenever you use different dummy variables for controlling the region from where the data is collected, that is called as region fix effects. Okay, you are controlling for the differences across region also. So if you just click on it, so you will get the results here also. Except constant, none of the variables are actually significant to interpret. Uh, and once you run the regression, okay, then you can go to statistics and scroll down. So if you click on post estimation, so from once you run a model, then click on post estimation. Okay, sorry, you have to go to statistics again and so post estimation, you will get all the diagnostics, whatever test that you want to do, uh, different types of prediction or different types of report, summary statistics, covariance. If you want to do any kind of test, linear test, contrast, pairwise comparison, or margins analysis, or any specification test that you want to do, diagnostics or goodness of fit. For example, you want to do the test of heteroscedasticity, or you want to do Ramsey reset test for omitted variables, Horseman test, information AIC and BIC criteria. If you just click and launch, you will get the result. So all the post estimation results will come here. Remember, first you have to run the model. If you run a Probit model, corresponding post estimation test, which can be used with Probit, that will come in this menu. So whenever you submit a paper to any publication in any international or any good journal, they will always ask you to do post estimation test. Have you tested for heteroscedasticity? Have you tested for robustness of the result? Have you tested for omitted variable bias? So if you have done all those tests and interpreted them, it gives an additional edge to it. And another advantage is that you don't know what post estimation test that you should do. You run the model, then go to post estimation. The possible tests that can be done will be listed here. So from that list, you can take, you can read about those tests and which test can be a suited one for the analysis which you are doing, and use those tests in the in your paper. So this is how you can use post estimation command. So I think most of the questions I have answered. Other things I will anyhow share the cleaned do file with you. But at the end of the session, don't forget to close the log file. Okay. So now we have some 5 minutes time for answering any queries that you have. So I have completed my portion here. From today, we will move to the extraction of data from text data, that is NSSO data extraction, annual industry survey data extraction, then periodic labor force survey data extraction, data handling. But for all those, if you want to understand all those things well, you should be thorough with the basic commands of Stata. You should not be, there should not be any confusion with this. So practice tonight also on these basic commands. You can take your own data set and practice. I will share my all the do files that I have. I will share it with you. If you still get any doubts, you can contact me anytime. So we still have some time for discussion if you want to ask any questions.